Hello everybody and welcome to this session. My name is Bjørn Lilleng and I work as a delivery architect at Capgemini Norway, and I'm currently functioning as a security architect for the project that forms the basis for this presentation.
And my name is Johan Sysæter, and I'm a senior consultant and the lead developer.
And the mission of the project is that we are creating a technological platform for certain health-related services for the Norwegian population. And right now we are in the middle of the project, and the services that we are providing currently, that was released about half a year ago, is only dealing with non-personal data, non-controversial data. It does some verifying on certain health services, but there are no controversial personal data there. So now we are approaching a stage where we are facing challenges with regards to personal data. And this is serious business, obviously. We have learned, on Monday that a large European airline was fined like 200 million euros for exposing like 400,000 personal records, including credit card data. Yesterday's news was that a really large hotel chain was fined about 100 million euro for exposing millions of customer records. So that the authorities are really taking this seriously now. And with that in mind, it's really good to know that it's possible to, if you combine technologies, for instance, what we have done using HashiCorp Vault together with event sourcing, it appears that if you compare that, if you try to map the technology, the security features that we're able to develop, and map that with the original 7 foundations for privacy by design, made or introduced by Anne Kovaklin back in the early 90s, it proves that we are covered pretty well. And so we'll come back to that, and Johan will have some live code as well to show what we're dealing with. So, but start with an overview. What we have is a platform as a service containing microservices. It's based on Pivotal Cloud Foundry. And inside this platform is a growing number of personal data that I mentioned. The current release only deals with other data that are less controversial. But at some point, we need our services to handle both sides, and especially the one in the middle that is called SPI Data, which means sensitive personal data or sensitive personal information, which requires special care according to GDPR Article 9, because that is data which combines both personal info and their health data, which really needs special care. And what the client system does, they expose certain services to locations, several locations around Norway. And the client systems use our platform to access personal data. Other client systems, they just access other data. But again, there are client systems that access the really sensitive ones, the data that combines all this. And so we do what we can to protect this. This is the platform is accessible via a private cloud by a Norwegian supplier, and the client system accesses the cloud from the internet. So we use various techniques like mutual TLS, both 2, anti-spoofing, and a lot of other techniques. So we have carefully designed a solution to protect the platform as good as we can. So that was the initial setup. When we got the contract from the customer, this was the initial plan. But after a while, the customer found out that, okay, we really need an admin interface here. And the client system are not useful to do administrative purposes. So they say that, okay, we need a VPN connection, so we need to take that into account. And after a while also they say that, okay, there are some governmental requirements that says we need to make certain reports and certain queries available for governmental use, because the government really wants to keep track of what we are doing. So that's a new requirement we need to take into account, and we need to let them get into our solution as well. And after a while, the customer also found out that the value of the data here is also interesting for others. So there is a commercial aspect here, which means that we need to make some of the information available also for the commercial actors. And we know that in the future, we will be challenged even more. So we got a lot of potential clients that is challenging our initial infrastructure. So this is kind of our concern. And in addition, of course, we have the kind of GDPR concern, which will punish us really hard if we don't do this correctly. So you really need to take care here. And because according to the law, as a data processor, in this context, we are a data processor, the customer is the controller. And under Article 28, the controller must only appoint processors who can provide sufficient guarantees to meet the requirements. So this means that the controller, our customer, trusts that we are able to provide such guarantees. In addition, we are required, according to GDPR 32, to use the best technology available to provide the security. It says state-of-the-art technology. So that's a special requirement for ourselves. In addition, GDPR says that the subjects, they have special rights, and they should be allowed to exercise the right under several GDPR articles, like the right to be forgotten, the right to be rectified, the right to be communicated in case of a breach. So there are several things that need to be taken into account here. And another thing is that it doesn't matter if only the security architect and the lead developer only knows about this. This must be a part of the team DNA, both all developers, all architects, project leads, everyone needs to be part of this. So we have introduced Zero Trust as a kind of an architectural state of mind. That's a team DNA, so to say. Which means that we want to develop security from inside out. We don't trust the barriers that we have created. We need to do it. We need that as well. But the important part is that we develop security from the inside. Make sure that we encrypt everything, all personal data. So this means there is a combination of processes and technologies. The technologies are really important, of course, and but the process on top of technologies must be available for everybody. And the customer has a tendency to say, okay, if we use too much time on security, that will take away the focus on all the functionality. But we say that if we never discuss functionality without also taking the security aspect in mind, that will actually be a business enabler rather than a business restriction, because that makes things that means you don't need to think about security all the time, because it's a part of your DNA. Also, things are user and application-centric. It's not about infrastructure here. And of course, least principle, you should only get access to what you really need to do the job. No implicit access. It's explicitly. we always verify that someone that tries to access personal data actually has access to it. And it's also based on context, which means that you may have access to personal data doing one thing, but that doesn't imply you have access to the same data in another context. So we really need to control the access here. So, and for the customer, they say that if we want to access other data, then it's probably open for all customers or all clients. If we want to access personal data, then you should restrict access to a lot of like government, commercial actors, what have you. And if you open a bit more, if you combine personal data and other data, and especially if you want to access only the sensitive private data, that should only be accessible from just a few client systems. And this makes it really hard. Just a small error in our own code or a vulnerability in a third party may open it all unless we do security from inside out. So the point is inside, any insider needs special permission. There are no kind of general opening here. They need special permissions to get access to the personal data. So what we need is a set of building blocks, and here HashiCorp Vault comes in very handy, because if you look at secret management, data encryption at rest, encryption data in transit, all these three areas we use is used for HashiCorp Vault. And for the last part, we not only use mutual TLS for the external communication, but also internal between microservices. And so we use HashiCorp Vault to handle the private keys. And using HashiCorp Vault this way, we have very nice zero trust building blocks.
Yeah, so I have been a developer for some time, and but I didn't get to know what it really meant to be compliant before the end of 2017, when the GDPR came into focus. And that's when I started to learn that I, as a European citizen, has the right to be right to privacy and the right to data protection, according to the European Charter for Fundamental Rights, and that we and all our clients have to implement these rights in order to be compliant. Now, the GDPR is mainly a reiteration of the General Data Directive, except for one thing, and that is that we now have to do data protection by design and data protection by default. But what does it mean to do data protection by design and by default? Now, data protection by design and by default comes actually from two terms. One is data protection, and the other is privacy by design and privacy by default. Now, originally, the European Commission used the terms privacy by design and data protection by design to mean the same thing. But in order to make a distinction between the right to privacy and the right to data protection, the data protection by design and data protection by default was chosen as the basis for many of the articles of the regulation. For example, Article 25, which is called data protection by design and by default. But still, privacy by design and by default is still considered an essential component for privacy fundamental privacy protection and privacy engineering, according to the European Commission. So, privacy by design by default is actually consisting of 7 foundational principles, and they were originally conceived by Dr. Anne Kawokian during the 90s, when she was the Information and Privacy Commissioner in Ontario, Canada. And so that is sort of like the, you can look at it as the manifesto for the GDPR. And HashiCorp Vault actually helps us to implement these foundational principles, for specifically in regards to data protection. For example, if you make your private data inaccessible by encrypting it unless and that you don't grant access to decrypt that data unless you're properly authenticated or authorized and audited, then you make sure that you are using a proactive and preventive approach to data protection, since you are assuming that an attacker can take control of your service and get access to your data. But even if he were to do that, the data would be encrypted and protected. And if you also use HashiCorp Vault for decrypting data by default, you're also complying with principle number 2, which is in regards to the default setting. And by encrypting data by default, we make sure that we are not exposing any data. So in this way, HashiCorp Vault actually makes sure that we can implement these principles, except for maybe principles number 6 in regards to visibility and transparency. Because in order to ensure visibility and transparency in regards to personal information and the processing of personal information, we have to be able to track changes to personal information. And the way that we have to do that is that we have to be able to know which operations are responsible for changing our personal information and why they are changing the personal information. But a very interesting architectural pattern for actually achieving this is actually using event sourcing. Now, with traditional databases, you can know where you are. You can know the current application state, but you have no idea how you got there. But with event sourcing, you are recording events and changes to the system as a sequence. And you can thereby be able to know how you were able to get to a certain point. So take, for example, your bank account. Your bank account is not a secure box where you store your money. Your bank account is a principal book or computer file for recording and totally economic transactions. And so when you take out, when you buy a T-shirt or you take out money from your ATM, and an event is registered, and as a event is registered for a certain transaction, and as a result of applying the sum of all transactions that have happened during a period of time, we are able to calculate our balance. And in that way, we're able to be able to track our spending so that we make sure that we're not using more money than we have. But we can also ensure that nobody takes advantage of us and charge us unreasonably for a T-shirt, for example. So in the same way, we can use event sourcing to ensure visibility and transparency as we are keeping track of all these events as a transaction log.
Yeah, so like Johan mentioned, event sourcing is kind of a track of historical events, like the transaction log on your bank account. Another very good example, which has relevance to our project, is your health record. The visits you made to your doctor last year would be a kind of a sequence of events, and that is a historical fact. You can't deny that. So this means that an event sourcing log is immutable. It can't be changed. That's pure history. So, so the point is that in event sourcing, we are writing and reading data is two totally different aspects. And the things that we write, the events that we write, they are never deleted. So that is seemingly a contradiction with regards to GDPR. If you look at the figure here, it says that on the left side, GDPR erasure is sometimes mandatory. For instance, to execute the right to be forgotten, and also data retention, Article 5, and also law requires sometimes that some report should be deleted after 3 years or after 5 years. So that also must be executed according to GDPR. Whereas in event sourcing, events are immutable and undeletable. So how do we solve that particular contradiction?
Yes, so to address these challenges in regard to event sourcing, what we can apply is a technique called crypto thrashing, which means that we encrypt the data using a specific key, and then if we want to remove that data, what we do is that we just delete the key, thereby removing the personal information that throughout the system. And we do that without actually changing the application state. But how do we use crypto thrashing in order to ensure that we have a GDPR compliant event sourcing? Well, what we can do is that we can create a specific key for each person. And I call this the pref key. And then I create another key for a temporal key for each retention period. And what I then do is that I apply double encryption by first using the pref key to encrypt the personal information for each data subject, and then I apply the temporal key to encrypt the complete personal data set during a certain retention period. Then when an individual comes and wants to exercise his right to be forgotten, what I can do is that I just delete his pref key. Thereby making all his personal information unavailable. But how does this work in practice? So what I've done is that I have installed HashiCorp Vault on my personal laptop, but I've also installed an event store from Axon IQ, which is based here in Amsterdam, for recording my events. And additionally to this, I have created a microservice for registering health treatments for elderly patients in need of medical assistance that's living at a home for elderly. So as you can see here on the Axon dashboard, I have here an overview of all the events that's stored in my event store. And as you can see, there's no events there currently. So I'll just go ahead and create some events. So I will register a health treatment by subscribing 20 milligrams of Brintellix, which is an antidepressive drug, for a patient called Jan Johansen. So let me see here. There. And then I will supply 20 milligrams of Brintellix to his brother Stig Johansen, as he has been depressed for many years now. There. So now if I go back to my event store, I can see that I'm starting to get some events here. And if you look here, if you're able to read this payload here, you can see that data is actually being encrypted by HashiCorp Vault. To be able to see this a little bit better, I've created an endpoint here. So here you can see the whole data structure. And as you see, the name is actually being encrypted. And for demonstration purposes, I have created another endpoint where you can see the data in unencrypted form. What we are using for encrypting the personal information is actually the transit secret engine. And the reason we are using that is mainly for two reasons. Reason number one, using the Vault secret transit engine, we can apply encryption as a service without actually exposing the encryption key. And that's actually quite important, because what if an attacker takes control over my service and steals my data? As long as the key is securely stored in Vault, the attacker will only have the data in encrypted form, thereby making sure that the data still is protected. And that's also a very important requirement in regards to GDPR if you're processing sensitive information. So let's say that you are processing sensitive information for the population of Amsterdam. If you were to have a data breach and hackers were to steal your data, if you haven't encrypted your information, you would have to contact each individual data subject individually and tell them about the breach. Now, that of course becomes impossible when you have such a large group of people. So instead of doing that, what you can do is that you make sure that you encrypt the information and that the decryption key is inaccessible to the attacker. So thereby you can ensure the supervisory authority that the data is protected even if it has been stolen. So now, but then what if then Stig Johansen dies, and as his final wish he wants to be have his personal data removed, as he doesn't want anyone to know that he was depressed for the final years of his life. So what I will do is that I will just delete his PREF. And the reason why I can just delete his PREF is that what I have done is that I have used a key derivation, which is a functionality for the Vault secret engine. And that means that I can use one key for multiple purposes by deriving a new key using a user-supplied context value. So what I'm doing is actually I'm taking user-derived context values and I'm using them for each person and for each retention period. So I'll just take his PREF here and delete it. So now, if I go back to the endpoint showing the decrypted data, I'm not able anymore to read the name of Stig Johansen, as the key that was used to encrypt and decrypt the information about him is gone. And in this way, I've ensured that his personal information is not only removed for this microservice, he's also removed through the whole system. And he's also removed from any backups and logs that has recorded any personal data about him. In the same time, all the events that was recorded previously also now is unreadable. So I have therefore ensured that that he can exercise his right to be forgotten. If I want to then do the same in regards to retention periods, the only thing I need to do is that I will just delete the context value for the specific retention period. So the first thing I would do is that I would take a snapshot of the current personal data set and using the key for the new retention period, and then I would delete the key for the old retention period, so that all the events and logs and backups that's generated during the old retention periods are completely unreadable and therefore removed from the system. So in this way, I can enforce Article 17 in regards to the right to be forgotten, and Article 5 about retention. So, but how then do I assure the data controller and the supervisory authority that I am in fact encrypting the personal information that has been flagged as personal? And the way that I'm doing that is that I'm actually using a small library that we're using as a library around Vault. And this library actually takes 3 values when encrypting and decrypting information. So it takes, first of all, it takes a JSON schema, and I have the JSON schema here. And then it also takes the context value, which is used for key derivation. And the third value is the data structure that I want to encrypt. Now, using JSON schema draft version 7, what I'm able to do is that I can actually specify which of the fields that I want to encrypt using the content encoding and content media types, which is defined as part of that standard. And so based on that, the library will take the fields that I want to encrypt and send them to HashiCorp Vault and back again. And then when the data comes back, what I will do is that I will just take the JSON schema and validate the encrypted data structure. So in that way, I am able to sort of like ensure that the data is encrypted correctly. And if the data doesn't comply, I will log a warning. And if everything is okay, I will just log an info statement. And then using that log output, what I can do is that I can actually test to see that encryption is being applied correctly. And when this schema then is in production, I can actually do a data flow analysis using my log output to be able to prove to supervisory authority that I'm actually doing encryption correctly in production. So, yes. So in this way, we are able to ensure that encryption is being done. But why am I using JSON schemas? Why am I not just implementing this in code, right? Well, the reason for this is that I want to be able to model how I'm doing the encryption in a data modeling software, so that the architects themselves can actually model how the encryption is supposed to happen. Then what they can do is that they can export those models directly as JSON schemas into version control code, thereby ensuring that I have end-to-end traceability from the design phase until the JSON schemas are in production, thereby ensuring that data is in fact encrypted and protected by design by default using HashiCorp Vault.
Okay, so it's quite obvious that HashiCorp Vault has proven to be really, really useful for us, and we use it in a lot of other arenas as well, like PKI, certificate management, and one particularly interesting area is that we need to do a lot of document signing, and we find HashiCorp Vault useful to perform such processes at all. So, but that's the theme for another session. So. With that, we thank you for the attention.
Thank you very much.
Okay.